We will now look at how to compute the derivative of the sum of two functions g of x plus h of x. Let's consider the example f of x equals x squared plus x. Remember that we just learned that the derivative of x squared is 2x and the derivative of x is 1, but what is the derivative of x squared plus x? In other words, how do we take the derivative of two functions added together? To answer our question, let's go back to our definition of the derivative using f of x equals the sum of two functions g of x plus h of x. Putting these into our definition, we have that f prime of x is the limit as delta x goes to 0 of g of x plus delta x plus h of x plus delta x minus g of x plus h of x, all over delta x. Distributing the negative sign, we get g of x plus delta x plus h of x plus delta x minus g of x minus h of x, all over delta x. But rearranging the top so that our g's are together and our h's are together, we get that the derivative is g of x plus delta x minus g of x plus h of x plus delta x minus h of x, all over delta x. Splitting the fraction up, we have g of x plus delta x minus g of x, all over delta x, plus h of x plus delta x minus h of x, all over delta x. But notice that what we have is the derivative of g plus the derivative of h. This means that the derivative of the function g plus h is the derivative of g plus the derivative of h. We can write this shorthand as g plus h prime equals g prime plus h prime. Or using our other notation, the derivative of g of x plus h of x equals the derivative of g plus the derivative of h. Using this, let's go back to our example. F of x equals x squared plus x. As we said before, the derivative of x squared is 2x and the derivative of x is 1. So the derivative of x squared plus x is the derivative of x squared plus the derivative of x, using what we just found. But knowing the derivative of each piece, x squared and x, we get that the derivative of x squared plus x is 2x plus 1. Let's use this now to compute some more examples. Consider the derivative of x cubed plus x to the 162. Since this is the sum of two functions, x cubed and x to the 162, we can use our newfound property to rewrite this as the derivative of x cubed plus the derivative of 162. And since these are just powers of x, we can compute their derivatives as 3x squared plus 162x to the 161, which gives us the derivative we were looking for. For our next example, let's look at the derivative of x cubed plus 1 over the square root of x. We have x cubed plus 1 over the square root of x. Breaking this up, we can rewrite it as the derivative of x cubed plus the derivative of 1 over the square root of x. We just computed the derivative of x cubed, but what about the derivative of 1 over the square root of x? To do this, we need to write 1 over the square root of x as a power function. We can do this as x to the negative 1/2. So we need to compute the derivative of x cubed and x to the negative 1/2. Using the power rule that we found in the last video, we get 3x squared plus negative 1/2 times x to the negative 1/2 minus 1, which is 3x squared minus 1/2 x to the negative 3/2. So the derivative of x cubed plus 1 over the square root of x is 3x squared minus 1/2 x to the negative 3/2.